Yes, dear students, in this video I will talk about equilibrium of rigid bodies. Actually, we are confused about equilibrium in physics, in mechanics. In mechanics, equilibrium. Equilibrium is taken regarding translatory motion. That is motion in a straight line. And rotatory motion. The body is said to be in translatory equilibrium if resultant of all the forces acting on body is zero. Vector sum of all forces acting on body is zero. Then body is said to be in translatory equilibrium. Translatory equilibrium. When resultant of all force acting on a body is zero, then body is said to be in translatory equilibrium. Now resultant of all force acting on body is zero. Resultant of all force is acting, here it is acting on body zero. So I tell you the body is said to be translatory equilibrium if resultant of all forces acting on body zero. From Newton's second law. From Newton's second law. We know vector F is equal to ma. So here if I say F is unbalanced external force, resultant force. F is resultant force here. If F is equal to 0, then ma is equal to 0 or a is equal to 0. If acceleration is 0, a means acceleration. If a is equal to 0, then either body moves with constant velocity or is at rest. Generally we think then when body at rest it is in equilibrium. Actually when acceleration zero, velocity changing, velocity not changing, body moving with constant velocity, then body also called in equilibrium, and that equilibrium is called dynamic mechanical equilibrium. We are talking here about mechanical equilibrium. Equilibrium word is used in different references, like chemical equilibrium, like harmonical equilibrium, society equilibrium. So when resultant goes zero, so F A equal to zero. So if body moves with constant velocity, then the equilibrium is dynamic equilibrium. But if at rest, if body is at rest, having all force zero, then the equilibrium is static. Actually, equilibrium is understood in many ways, not single ways. So it is about the translatory equilibrium. So body at rest is in equilibrium. Body in motion with constant velocity is also in equilibrium. These are simple terms which creates lot of trouble, lot of problem for us. Now, rotational equilibrium. Rotational equilibrium. Rotational equilibrium. Actually, rotational acceleration produced by torque. If vector sum of all the torques acting on a body, vector sum of all torques, or you can say moment of force, moments of forces acting on a body is zero, then the body is said to be in rotational equilibrium. equilibrium. We can apply both condition of all equilibrium on a body, single body, forces and torque. But in general, I can say here, in general, if resultant of all the forces and torques acting on body is zero, then body is said to be in equilibrium. If resultant of all force and all torques acting on body zero, then it is the overall condition for equilibrium of body. I will discuss here the equilibrium of any rod supported at different points and equilibrium of a ladder also. So here first I take equilibrium of one thing more here. There are many things about equilibrium and people are confused because their things are not learned properly. We are always in hurry. We want to finish as early as possible, but this is not good. एक जिक्र आता है स्टेबल इक्विलिब्रियम. स्टेबल इक्विलिब्रियम by equilibrium तो net force, net torque zero, that's all. But why stable and unstable? I will demonstrate here. This piece of duster is on my hand. If I raise it little and release it, come back. I take it up and release it, come back. It is in stable equilibrium. But if I make it stand like this, and I gently displace, it does not come back. It does not come back to original condition. Thing is same, but in one situation it is in stable equilibrium, and here it is unstable equilibrium. Then what happens to equilibrium? Why the equilibrium is lost? When a body is in equilibrium, a body in equilibrium is displaced from equilibrium condition, equilibrium position. And on releasing it if torques and forces are produced, if torque and forces produced, torques and forces produced carry the body in original position, then body is said to be in stable equilibrium. Stable equilibrium. If torque and force are produced in such a manner, body goes back to original position. But if torques and forces produced carry the body away from its original situation, then equilibrium is unstable. Dear student, it is very difficult to understand the topics if resultant of all talks. You will get the topics in class 12. One thing more about stable equilibrium. There is a criteria of energy possessed by body. In stable equilibrium, the system of bodies or single body is said to be in state of lowest energy state. Lowest energy. Now, stable equilibrium. And unstable is above the lowest energy level. That also will be seen in many topics, in which orientation the system is in situation, the system has lowest energy. So where is stable equilibrium? But stable equilibrium further depend on so many things also. So this was about the definition of equilibrium, stable, unstable, dynamic, static, rotatory and translatory equilibrium. In next video I will talk about equilibrium of a rod supported at different points, and then equilibrium of a ladder leaning against the wall.